Okay, so today's session is again very important session. It is the second part of your analysis, and our first analysis, our first lecture focusing on analysis, it generally talked about coding of data and doing validity analysis, validity, ensuring validity of our questionnaire. In this particular lecture, we will be discussing about checking for reliability. We will discuss how to make indexes. We will check for normality. We will test hypotheses. We will interpret our hypotheses. So the remaining steps in our analysis will be discussed in today's session. The agenda for today's session is that we will be focusing upon these 9 different steps. First of all, I will discuss how to report factor analysis table. There is a particular way by which you report factor analysis table. I will try to construct that table for you. I will show you how that table is constructed and how that table is interpreted. Calculating the reliability of your data. Then we will discuss how to check for the normality of the data, how to interpret the normality of the data, how to make indexes. I will show you how to conduct and interpret t-tests, how to conduct and interpret ANOVA test, and how to conduct regression test and how to interpret it. And I have been receiving lots of queries regarding how to convert Excel file to the SPSS file. I will show you in few steps. And one very important thing which you need to keep in mind before starting your analysis is that you should make all your questions positively worded in your software. So how to code negatively worded questions in the data, I will show you in today's session as well. So these are the 9 tasks which we need to learn in today's session, and therefore I think so. Our lecture might extend beyond our allocated time. The agenda for next session is also very clear. We will be discussing about moderation analysis and its interpretation, mediating analysis and its interpretation, and analyzing secondary data and how to interpret it. So our agenda for next session will also revolve around analysis as well. Okay, so let me begin our today's agenda, which is, first of all, we need to understand how to report factor analysis table. Now, let me share screen with you guys. Okay, so we ended our last session at this particular junction. So this was the, table which was produced as a result of our factor analysis. So this was basically our factor analysis table. So we, when we copied this table and when we copied this table to our, report, it looked like this. So this was the table which was copied to our report. So when we copied this table to our research report, we need to make certain changes. We need to transform this table to this particular form. So we want this table in this particular form. So there must be like 1, 2, 3, 4, 5, 5 columns in the table. The first column depicts the codings. The second column depicts the statements, the questions, and the third column, it demonstrates the factor loadings, and the fourth column it measures the reliability, and the last column measures the variance explained. So the information in the first column, in the factor loadings column and the variance explained column can easily be, extracted from factor analysis. Okay, there is no problem there. But we need more information in this table as well. For instance, what is the statement? What is the question that is denoted by this particular code? We need to open our questionnaire. We need to see that what was the narcissism 3 questionnaire. We will copy that question and then we will paste it in our table. So this particular column, statements column, it basically depicts the questions which were denoted by these particular codes in our software. So narcissism 5 question is basically this particular question. How we know it? Because we have our questionnaire. Our fifth question is this particular statement. It is wise to keep track of information that you can use against people later, and we copied that statement to our this particular column. Loadings are basically the same things which we discussed, which we extracted in our factor analysis table. So these are the statements, these are the values which are denoted by these particular items. So narcissism 3 has a factor loading of 0.800, and why it has a factor loading of 0.800? Because it emerged like this in our factor analysis, as a result of our factor analysis, and we have depicted with the same value here. So I'm just demonstrating that how you should depict your factor analysis table in your research report. Now, how would we know about variance explained? Now, we need to know about the variance explained through our factor analysis. This is shown in the total variance explained, um, uh, you know, table in your factor analysis. Just click at total variance explained table and just look at the second last column of that table. The second last column of the table, it shows the variance explained by each factor. So the first factor is narcissism. The variance explained by this factor is 18.53. So we will write it here, 18.537%. Now what does this variance reflect? It shows that how each factor is contributing to the factor solution. So the most important factor will contribute more, and the other less important factors will contribute less. So our narcissism is explaining 18.537% variation in our data. So it is a very, very important factor for us. Our second factor is, COVID fear, and it is again explaining a very good variation here, 18.166. So we will write here 18.166. So here the names of the variables are not written; they are just denoted by their numbers. So we have four variables. The first variable is narcissism. It is explaining 18% variation. The second variable is COVID fear. It is explaining again 18% variation. The third variable is, let me see from the table, uh, Machiavellianism, and it is explaining 13.047% variation. So this is not as important as the variable of narcissism is. So this is the third variable. It is explaining 13.047 variation. The fourth variable is explaining 10.557% variation. So the fourth variable, which is the psychopathy variable, is explaining 10.557. Let me check it again. 10.557% variation. So this explains to us that the most important variable is narcissism. It is explaining 18.5% variation. The second most important variable is COVID fear. It is again explaining around 18% variation, and subsequently Machiavellianism and psychopathy fall in terms of their importance in our data. So this is also very important for you, that you also outline the variance explained by each factor. This is very, very important, part of your factor analysis table. Now, at the end of this table, you need to tell us the overall variance. So overall variance will be like, we will simply add these four numbers, or if you have three variables, you will add three numbers, and then you will just give the figure. We can also look at this from our table. This The last column is basically cumulative variance. So last column shows us that our overall variance is 60.307. So our factor solution is explaining 60.307 percent variance, which is very, very good. Why? Because this particular number, overall variance, it must be above 45%. If this is not above 45%, then your factor solution is not very solid. So if you want your factor solution to be very solid, it should be very good. This value, the overall variance, must be greater than 45%. If it is not greater than 45%, then we have serious doubts in your factor solution. Okay, now let us calculate the reliability. So we will only calculate the reliability of those questions which are part of our analysis. Those questions which are deleted from our analysis as a result of factor analysis, which are invalidated as a result of factor analysis, we will not include them in our analysis. So in narcissism, we have 7 questions. Overall, there were 9 questions. So we have the two remaining questions of narcissism will not become part of our analysis. So all those questions which were initially part of your questionnaire, but they are now deleted as a result of factor analysis, they will not become part of your analysis again. So let us, check the, reliability of each, factor. We will check their reliability separately, and then we will check their overall reliability. So let us check their reliability individually. Okay. So in order to check the reliability, we need to go to the analyze button. We will click on an analyze button, and then we will go to the scale. When we open the scale button, we have this option, reliability analysis. So again, I will show you analyze. From analyze, we open a scale, and from scale we will choose reliability analysis. So I have already calculated this. I will do it again for you. So we need to put our items, we need to transfer from this left window to our this right box. The box name is items box. We don't need to choose this ratings box. We need to choose items box because these are our questions from our questionnaire. So those questions which are now part of our analysis, which are part of our factor analysis table, we will only include those questions. Those questions which are no longer part of our analysis, they will not become part of any test, any statistical test which we will be conducting from there on. Okay, so the questions narcissism 1, 2, 3, 4, 5, and 7, 8. So these 7 questions, they need to be put in that item box. So narcissism 1 to 5 is there, and then we have narcissism 7 and 8. So let me confirm it, narcissism 1 to 5, and then we have 7 and 8. Okay, so we have transferred the items from the left, box to the right box. The box title is items. We don't need to do anything else. We will just, check this, how they are, all the items which are part of our factor analysis are there or not. All the items are there in this factor. So we will just click OK. And when this analysis is run, reliability, we are particularly interested in reliability statistics. We are interested in this particular statistics. So this is a table. This gives us Cronbach's alpha, and the value is 0.821. So we will write it here, 0.821. So this is the value which is discussed, which we have extracted from our reliability analysis. This is a very good value. Why? Because this value needs to be greater than zero point 0.6, and this is greater than zero point 0.6. So this is a good number. This shows that these 7 questions, they have very high internal consistency, and that is why they are reliable. So we will be using internal consistency type of reliability in our analysis. So this scale is not only valid, and it is also reliable. That's good. Now let us check the reliability of remaining factors. Like we will check the reliability of COVID fear. Question number 1, 2, 3, 4, 5. There are 5 questions of COVID-19. Let us go towards the analyze, then scale. From scale, we will check, we will choose reliability analysis. We will reset because there is narcissism already there. We need to choose the first 5 questions of COVID fear. We will put it in our item box. We will click OK. Again, we will check the reliability statistics. The answer is 0.855, which is very good answer because it shows that the value is greater than zero point 0.6. It shows that our questions measuring COVID fear are internally consistent, which is a very nice result for us. Similarly, we will check the reliability of Machiavellianism. The question number 5, 6, 7, and 2. Let me check. Let me try to check the reliability of this particular, question, this particular factor. Question number 2, 6, 7, and 8. Question number 2, 6, 7, and 8. Let me confirm it from here. Question number 2, 5, 6, 7. Sorry, there is a mistake here. 5, 6, 7. So There is no question number 8. So I have just put, I have just transferred the four questions of Machiavellianism to the right box, and then I will click OK, and there is a trouble here. There is a problem here. The problem is that my reliability value is in negative. It shows that there is a huge problem here. The reason is this, that I I basically you know I was I made a mistake here because I did not convert my negatively worded questions. This is the problem here. Very big problem. I did not convert my negatively worded questions. So let me show you again that which questions were negatively worded. Let me show you in my questionnaire. So these are the questions which are negatively worded. Question number 6 and question number 2. And fortunately or unfortunately, these questions are also part of our analysis. So question number 2 and question number 6, these questions are negatively worded. They are reverse questions. So the question is, I hate being the center of attention. So here it means that we need to reverse them. We need to reverse code them. So I will show you now that how we will reverse code them. We will just we just need to remember that there are two questions here, question number 2 and question number 6. These two questions are also part of our table, question number 2 and question number 6. Now I will go to the transform button. I will go to the recode into the same variables. Remember that what we are doing at the moment is we are basically doing this step, learning how to code negatively worded questions in the data. So there we now we get to realize that these negatively worded questions in the data, they are creating trouble for us. We are not able to measure their reliability. They are not reliable, as per our data. But I just realized that I did not convert my questions. I did not convert my negatively worded questions to positively worded. So we basically asked these questions. These negatively worded questions were asked because we wanted to check whether our respondents were attentive enough to fill the responses or not. But somehow I was not able to convert them into positive mode before my analysis, which is a mistake. Before conducting your factor analysis, you need to convert these negatively worded questions to positively worded questions. So let me show you how to do this. So these are the two questions which need to be converted. I will show you again. I went to the transform button. In the transform button, I chose recode into the same variables. And here I will choose the two questions which were creating trouble for us, Machiavellianism 2 and Machiavellianism 6. Let me input the values. So these are the two negatively worded questions. One here stands for 7. Two here stands for 6. So 3 here stands for 5. And 4 will stay the same. 5 here stands for 3. And 6 here stands for 2. And lastly, 7 here stands for 1. Now, why I have done these, transformation? Because if you read this question, I hate being the center of attention. Basically, the question is, I love being the center of attention. And if someone is disagreeing with this statement, it means that someone, if we transform this question, if we reverse this question, the responses will be reversed as well. So when we are reversing the question, when we are converting the negatively worded question to the positively worded question, we need to reverse their responses as well. So originally, if this particular question was answered as 7, and when we reverse this, we need to reverse the answer as well. So 7 will become 1, 6 will become 2, 5 will become 3, 3 will become 5, and 2 will become 6, and 1 will become 7. So this is what we are doing here. We will just continue with it, and we will click OK, and we will run the analysis again. We will go to the scale reliability analysis. Again, the four questions are there. So let us see whether we are able to solve the issue here or not. I will check the reliability statistics. Here the answer is 0.699. So I just checked the last answer. It was minus 1.390. So the the value should never be negative. We are saying that the value should be above zero point 0.6, at the positive zero point 0.6. So the value was negative. I just realized that there are two questions which were negatively worded, and I did not convert them into a positive form. So I just went into the transform button. I just chose this option, record into same variables, uh, you know, change their values, continued. Then I just clicked OK, run this analysis again, and I have now very good values. The value is 0.699. So this shows that my this factor is reliable as well. So when I you know uh, so when I converted it into positively questions, I need to revise the statements as well. Okay. So when I say I hate being the center of attention, I should say I love being the center of attention, or I can simply use the word are here. Okay, so I can simply use the word are here, or I can simply use the word are here as well. So these were the two questions which were basically negatively worded. So I have now converted them into positively worded questions, and the result is good as well. Our last variable is psychopathy. We need to calculate its reliability as well. I will go to the analyze button. I will go to the scale button. I will check reliability analysis. I will reset it. The three questions of psychopathy include question number 2, 6, and 7. So question number 2, 6, and 7. I will find it here. 2, 6, and 7. I will transfer it to the items box, click OK, and this is very nice. No, this is not nice because the value is below zero point 0.6. So it means that this factor is not that reliable. But which questions are making problem for us? So let us try to find out those questions. So I will go to the again reliability analysis. I will click on the statistics table button, and in the statistics button, I want to check this box because this box will tell me that which questions are creating trouble for me, that my reliability value is below zero point 0.6. I want to pinpoint that question and I can remove that question so my reliability value can increase beyond zero point 0.6. So I will just check this box, scale if item deleted. I will continue, and then I will click on OK. Now, scale when item is deleted, it is basically reflected by item total statistics. So I want to read item total statistics. So question number 2 of psychopathy, if it is deleted, the value of reliability reduces further. It reduces to 0.506. So it means that it is an important question because if we delete this question, the value reduces from 0.59 to 0.506. Question number 6 of psychopathy. If I delete it, then its value will reduce further, from 0.59 to 0.46, which is not good for me. Similarly, for question number 7, if I delete it, the value will reduce from 0.59 to 0.506, which is not good. So it means that all the three questions are equally important to me. Secondly, uh, in in your research, you cannot, delete questions. If a factor has a single question, it is not acceptable. One variable must have at least two questions. So even if we, try to delete these questions, we are bound by limitation because the minimum number of items must be two. So we have the minimum number of items. We have three number of items here, which is acceptable. But if we had two items, then we cannot delete any item at all because a minimum number of items in a single column in factor analysis must be two. I will again repeat it here. So minimum number of items in a single, column must be two. Then it will constitute a factor. Then it will constitute a variable. Otherwise, it will not be a factor. It will not be a variable. So this is a thing which you need to keep in mind as well. Okay. So now all the three questions are important because if we delete any of these questions, the value reduces from the original value, which is 0.592. So what should we do now? We are facing a reliability issue here. I will just write the original value 0.592 and just try to check the overall value. What is the overall reliability value? If the overall reliability value is sufficient, it is greater than zero point 0.6, then I will be, I will not be too much worried about this particular factor, because all other factors have values greater than zero point 0.6. And even if one variable has a value of reliability lesser than zero point 0.6, but overall reliability value is good, it is sufficient, then I don't need to worry about it. So I will just check the overall reliability by including all these questions in my analysis. So I will again go to the analyze, I will go to the scale, I will check the reliability analysis, and I will just include all those questions which are part of my factor analysis table. So I will just shift the narcissism, I will shift the 5 questions of COVID fear and Machiavellianism. The questions of Machiavellianism are 2, 5, 6, 7, I think. Yeah, I just confirm it from here. 2, 5, 6, 7. Okay. So all the questions in our factor analysis table are there in the items box. I will just click OK, and I am just interested in the reliability statistics. Okay, so all the 19 questions, they have the reliability statistics of 0.751. So this is good, this is very good, that my you know alpha reliability, or my reliability coefficient is greater than zero point 0.6. It is in fact it sits handsomely at 0.751, which is very nice. So overall reliability is greater than zero point 0.6. It is very nice. It is a good result, even though one value, one factor is below zero point 0.6. But still, my overall, reliability is greater than zero point 0.6, and all other three factors, they have sufficient reliability as well. So I would say that data is fairly reliable. So now I have, confirmed the validity of my data by deleting all those questions which were not validated. I have also confirmed the reliability of my data. Remember that when you are constructing your factor analysis table, you need to ensure that overall variance, it shall be greater than 45%. So this variance, the variance explained by each factor, it must be greater than 45%. Uh, we have sufficiently passed that criteria as well, because our variance is greater than 60%. No single factor should explain more than half of overall variance. This shows that the half of overall variance here is 30, right? 30.1, 15%. So the half of overall variance is 30.15%. So no variable should have variance more than 30.15%. Why? This shows that only one factor is explaining. So if suppose that if variance explained by one factor is more than half of overall variance, like if one factor, suppose that the first factor is explaining like say 31% variance, so it shows that this variable is basically more and all other values are very less, like 8, like 7, like you know 10, etc. So overall value is like 60. So this shows that this one factor is basically the most important factor, and this is explaining the highest variance. It is like your group work, where one student is doing the majority of the work, and all other students are very passive, they are not contributing. So overall that group's work cannot be called as a very efficient or very effective teamwork. It is like a sports team, like a football team, where only one player is playing excellent, and all other players are not, they are just, playing very mediocre game. So we cannot call that team as a great team. So that is why we have to see that no single factor should explain more than half of overall variance. Luckily, in our, factor analysis, no single factor is explaining more than half of the variance. So we have sufficiently passed this criteria as well. The reliability value must be greater than zero point 0.6. We have discussed this as well. Although our one factor has a reliability lesser than zero point 0.6, but our overall reliability is sufficient. So it means that we can confidently say that our data is reliable and valid. So you need to construct this table, and you need to report this table. We don't need this table. Okay, so you don't need this table in your analysis. We need this particular table in our analysis. Okay, so how to explain this table in your report? So I had just given an example. You need to interpret this table like this. For instance, if you are, explaining first factor, narcissism, all questions measuring narcissism factor loaded separately. Two questions which were found to possess validity issues were removed. These questions were narcissism 6 and narcissism 9. It would be better if you write the statement of the questions because we don't know, readers don't know what are the questions of narcissism 6 and narcissism 9. So it would be better that if you write the actual statements of these questions. So let me write here narcissism 6 is you should wait for the right time to get back, and narcissism 9 this. So you should write the statements here. The total variance explained by this variable is 18.537%, and the reliability of this factor is found to be adequate as Cronbach value is, I should say, as reliability coefficient is reliability coefficient is 0.821 as shown in your table. So this is good. Okay. So similarly, we will discuss other factors as well. And after that, at the end of this table, at the end of the discussion, we will conclude it that overall reliability of data is adequate at 0.51, and the total variance explained by our factor solution is 60.307%, which is reasonable as well. So we will explain these two values as well. So this is how you will interpret your factor analysis table. So we are done with three important tasks. We are done with the reporting of factor analysis table. We are done with the calculating the reliability of our data and learning. We have also learned how to code our negatively worded questions in the data. Okay, any questions so far? Any problem? Anything which is not clear? Any ambiguity? Any questions so far? Anything which is not clear? Okay, I will continue. If any question pops up in your mind, please don't hesitate to discuss with me. So we will now discuss checking for the normality of the data. Okay, so basically, let me first show you how would we check the normality of the data. First, we will go to the Analyze button, and in Analyze button, we will choose Descriptive Statistics, and there are various options there, but we will choose descriptives. So here, all those questions which are part of our factor analysis table, all those questions which are part of our factor analysis table, they will be transferred from the left column to the right column, which is named as variable. So all the questions which are part of our factor analysis table will be shifted from the left column to the right column, which is the variables. And then we will go to the options. In the options, sorry, options will look like this. Okay, so in the options we will okay, this will be the default window. So when you open the options, this will be the default window. So here we are interested in distribution, normal distribution. There are two options we need to check: the kurtosis option and skewness option. And I think you can uncheck these two options, minimum and maximum. It just makes your table more crowded. So we need to have this choice in the descriptive option. We need to uncheck minimum maximum, and we need to check kurtosis and skewness, and they will continue. So only those questions which are part of our FET analysis are here. Those questions which are deleted, like these questions, they are all deleted questions. Okay, so these are all deleted questions. Mac 1, 3, 4, 8, 9. These are all deleted questions. So these deleted questions are not part of our, normal distribution. And these, sample questions are also not part of our, normal distribution. Okay, so those questions which are part of our FET analysis are here. We have put them in our variable, box. And from options, we have checked kurtosis and skewness. We have unchecked minimum and maximum. And now we will click on OK. This will give us the results whether our data is normally distributed or not. I'll click on OK. And so this descriptive statistics table, the descriptive statistics table is very important. So you need to read this table. You need to understand this table. Okay, here I'm particularly interested in skewness and kurtosis. So I'm interested in skewness and kurtosis, and I'm interested in the statistic values. These values, I'm interested in these particular values. In kurtosis, I'm again interested in statistics. I'm interested in these values. So what do these values tell me, and how can I interpret these values? Let me show you. So usually, when we are checking for normality, we are following this criteria that is devised by Hare et al. And Bryan 2010. They say that the data is normal if skewness is between -2 to +2 and kurtosis is between -7 to +7. So we will check our responses here and see whether our responses are following this particular criteria or not. So skewness is between -2 and +2. So this is being followed here. All the responses are either on positive side or negative side are between -2 and +2 range. So all our responses are normally distributed according to this criteria. Kurtosis, it must be between -7 and +7. So when I look at this, it is like very much within the range. So I have all the values are between -7 and +7. So I will just simply I will copy this particular table and I will paste it here. This is a table which tells me that my data is normally distributed. So I will just argue in my analysis section, in my results section, that according to the criteria of Hare et al. 2010 and Bryan 2010, and I will give the references of these two scientists as well, these two research papers as well, that data is considered to be normal if skewness is between -2 and +2 and kurtosis is between -7 and +7. And as shown in table, give this table a name. None of our questions, none of our items, they have they have gone against this particular criteria. So our data is normally distributed. So you can simply write these statements and this would be it. This would be sufficient for interpreting that your data is normally distributed. So this is a very simple statistical analysis. You go to the analyze and you choose descriptive statistics, and there in descriptives you will just choose those particular questions, those particular items which are part of your factor analysis. Those questions which are not validated will not be part of your analysis. So this is how you will conduct your normality test. So let me see. Yeah, we have conducted, we have concluded we have checked for normality as well. Any questions so far? Any ambiguity? Anything which is not clear? So I will give you the sequence, I will give you the template, and you need to follow that template while analyzing your data. So there will be a sequence of presenting your information. So at the moment, I'm just telling you that how you need to present your information. The sequence will be shared with you later. So anything which is not clear, please feel free to discuss with me. Anything? Okay, now we move on to our next task, which is how to make indexes. Now, first we need to understand the purpose of making indexes. So I will again refer to my factor analysis table, because this table will now it will become the source of analysis in our data. So this particular table basically tells you that there are 7 questions to measure narcissism. So does it mean that we need to measure narcissism in 7 ways, in 7 different types, or in 7 different 7 times? We need to have a singular value of narcissism. So this is what index will establish. Now we need to have singular value of narcissism. We need to have a singular value of COVID fear, and similarly we need to have singular value of these two factors as well. So we need to have a singular value in our, of each factor. So each factor should be represented by a singular value, and this singular value will be, established through index. Now I will try to make an index and show you that how indexes are made in SPSS. So I'll go to the transform button. In the transform button, there is an option. The first option in transform button is compute variable. I will choose the compute variable. I will reset it. Let me reset it. So I will choose compute variable. This would be like, the interface. So here I need to, uh, calculate the index of my variable. So I will first calculate the index of my first variable, which is narcissism. Now in narcissism, this question, narcissism 3, is the most important question because its weight is 0.800. And the last question, narcissism 1, it is the least important question because its weight is 0.586. Now, I will not be taking a simple average because simple average assumes that all the questions are equally important, which is not the case. So I will take a weighted average, and this question will be given more weightage and as compared to the questions which have lesser weightage. So I will just take narcissism 3 now. So narcissism 3 will be, search from this column at the left hand side. I have chosen, narcissism 3. First of all, I need to have a bracket here. So narcissism 3 will be transferred with this arrow in this numeric expression box. This is the multiplication. I will multiply it by its weight, which is 0.800. Then I will add, and then I will, uh, you know, uh, find out the, place these other variables. So narcissism 2 is there. I need to shift narcissism 2 there. The weight of narcissism 2 is 0.770. I will write that weight. I will add with my third question, which is narcissism 8. Narcissism 8 will be transferred there, multiplied by its weight, which is 0.703. I will add it here. Then I will, choose the fourth variable, which is the fourth item, which is narcissism 4. So narcissism 4 is again shifted there, multiplied by its weight. Its weight is 0.676. And similarly, we will, add other items there. Narcissism 5, 7, and 1. So narcissism 5 weight is 0.668. Narcissism 5 is shifted there, 0.668. I will add it here. Then we have 7, narcissism 7, and narcissism 1. Narcissism 7 has a weight of 0.620, and narcissism 1 has a weight of 0.586. Okay, I will remember it. 0.586. Okay, so I will divide it by 7. Why? Because total number of questions are 7. Simple mathematics here. The name of this variable will be narcissism. So the target variable is narcissism. So I'm creating a new index, and this index will be a singular value which will denote the all other questions in narcissism. So all the 7 questions under narcissism factor will now be represented by a singular value. So I will click OK. Okay, so they have already I have already created it, but I will just say it. Okay, so now a new variable will be created here, narcissism. Okay, so there is a new variable here, narcissism. So now instead of taking, separately, instead of measuring narcissism separately, I need to take only a singular value of narcissism now. So similarly, I have already calculated the indexes of COVID fear, psychopathy, Machiavellianism, and like narcissism was the the most the lengthiest variable. It has 7 questions. All other have fewer questions. So now we have calculated the index of all the the factors which are in our factor analysis. So all the 4 factors in our factor analysis have now indexes. So any question about index making? So now I need to show you that why we are not taking simple average. So let me just remove weights from here. I am just removing weights here. So these weights are removed from here. These weights are being removed. I just want to show you that why we are not taking simple average here. We are just adding the 7 items here. Instead of multiplying them with their weights, all the 7 items are added here, and they are divided by their total number. I would name it as Nazism average. Nazism. Okay, I will click OK, and I will just see there. So a new variable is is created here. When you go to the data view, just see the numbers. This is the weighted average, which we just calculated by multiplying each question by its weight. Now this is the simple average. Just see that how simple average has exaggerated values. Like each value has, it has exaggerated number, it has exaggerated values. But weighted average, it has, more subdued numbers. So in weighted average, we have given importance to the factors, importance to the questions on the basis of their weight. So all questions are not regarded equally important here in the weighted average. But in simple average, all questions are regarded equally important. So that is why this is an exaggerated value. Just say that all the values, almost all the values, our weighted average is lesser, as compared to the simple average. So simple average is just exaggerate your value. So that is why I would suggest that you don't need to take simple averages. Take weighted average. Okay, is it clear? Any question so far? So we are done with our this task as well, making indexes. So we need to transform our data and make indexes. Okay, so we have made the indexes of all the four variables in our data. Remember that our original, uh, you know, theoretical framework was like this. Narcissism, Machiavellianism, psychopathy are our IVs, and our COVID threat is TB. So these are the four variables, and now we have our four indexes as well. So it means that your number of indexes will be like it should be equivalent to the number of factors in your theoretical framework, the number of variables in your theoretical framework. Okay, so we are done with making indexes. So what's next? Now we will start, uh, you know, checking for these tests. Now I will show you how to conduct and interpret t-test. Then we will, conduct ANOVA test and regression test subsequently. Okay, first of all, t-test. So there is a conditionality for t-test. You can only conduct t-test when your IV has two response categories. When your independent variable has two response categories, then you can conduct a t-test. But when your independent variable has more than two response categories, then you will conduct ANOVA test. So let us just go to our variable view and see that which of our variables have two response categories. Gender, it has two response categories. Prefer not to say was not used by any of our respondents. So all our respondents are between male and female. So it has just two response categories. uh, Income, it has more than two response categories, so it means that it will be measured on ANOVA. Education, again on ANOVA. Profession, again on ANOVA. But measure these variables only when they are part of your research. If your hypothesis does not involve gender, income, education, you don't need to conduct these particular tests. For instance, I would say, so this is particularly, let me just show you hypothesis. So these hypotheses are answered by a t-test. So the hypothesis is there are significant differences between males and females with respect to their perception of COVID threat. So if gender is a relevant variable and you are answering this particular hypothesis, then you need to use t-test. Otherwise you don't need to use t-test. So it is not important for you to measure, to go for t-test or a nova test, unless and until your variables, your variable of interest require to be measured on these particular tests. So I'm just showing you how to conduct t-test, because some of the the students, they are using t-test, they are using gender as a variable here. So whenever IV has two response categories like males and females, they are two response categories, and then we will be using t-test. So t-test usually they give, they inform us about such hypotheses like there are significant differences between males and females with respect to their perception of COVID threat. How to conduct these tests? We will go to the analyze button. From analyze button, we will choose compare means, and from compare means, we will choose our third option here. The third option is independent samples t-test. We will click it. So this interface will open up. The grouping variable here basically refers to your IV, which has two response categories, and test variable here, it refers to your DV, where you will measure these, male female, regarding their perception. So grouping variable is your IV, which has two response categories. So here our gender is a grouping variable. We will put grouping variable here. Now software requires us to define these groups as well. So just look at our groups. Our first group is male, and our second group is female. Our first group is represented by 1. Our second group is represented by 2. So we will simply define groups by defining group 1 as 1, defining group 2 as 2. That's it. Because we have used the numbers of 1 and 2 instead of using numbers like 0 or 1, or using numbers like 2 or 3. So we have used 1 to denote our group first, and we have used the number 2 to denote our group 2. So this is just a simple classification. So we have defined our groups by numbers 1 and 2. So which particular variable we are interested in testing? So we are interested in testing COVID fear. So our hypothesis is basically that males and females, they are different from each other in their perception of COVID threat. So we are saying that males and females will have different perception of COVID threat. Maybe females will, they are more, they feel more threatened by COVID as compared to the males. So this is just our hypothesis. We need to check our hypothesis. So we just, put our DV, our COVID fear there. That's it. We don't need to do anything in these buttons, options, and bootstrap. So we have just transferred our IV, which is gender, which has two response categories here. We have defined the groups, and our testing variable, which is the dependent variable, which is the COVID fear index. So we have used index now. So remember, now for our t tests, for our ANOVA test, for our regression test, we will be using indexes only. We will not be using the other values. So we will only be using indexes for these particular tests: t-test, nova test, and regression test. So we have I have I have just transferred this index from the left table to the right table. The right box with the name of the box is test variable. I click on OK, and here I'm interested in two tables. The first table is group statistics table. Just by clicking it here, it is just it becomes obvious here. And the second table is independent sample t-test table. So these are the two tables I am particularly interested in, and these two tables will inform me whether my hypothesis is accepted or rejected. So I can just simply look at one value and make this inference that whether my hypothesis is accepted or not, whether there are differences between males or females. So first of all, I will look at the group statistics table. So if I look at male, their mean is 3.1. And if I look at female, their mean is 2.94. Remember that in our analysis, COVID fear was measured on 1 to 7. 1 stands for disagree and 7 stands for strongly agree. So this shows that our mean is around 3, which means that both groups have means around 3. And if you see that males, they are more, their perception regarding COVID threat is much more higher as compared to the females, because they are leaning towards neutrality. They are more towards, their mean is high, but the mean of females is less. So in our particular question, the 1 stands for strongly disagreement, and 7 stands for strong agreement. So this shows that if you have values closer to the 1, it means that you are not perceiving COVID as a threat. And if you have values closer to the 7, it means that you are perceiving COVID as a threat. So in this particular situation, the values, there are differences in mean between males and female. But is this difference significant? This is the question. We know that there is a difference, but this difference is very minimum. See that there is 2.94 and there is 2.3.1. It is very, 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 very close to each other. So how can I know that whether this difference is significant or not? I will go to the second table, which is independent sample test table. Now, in this particular table, I need to check on this column, significant two-tailed column. This is the column which I need to check it. So this particular column, I will basically check the second value, which is 0.177. So I need to check this particular column, significant two tail, and in this particular column I need to check upon the second value, which is 0.177. Now this value is greater than 0.05. This value shall be smaller than 0.05. Then we can say that differences in mean are significant. But now, because this value is greater than 0.05, then we can say confidently that there are differences, but differences are not significant. So it means that our uh, males and females, they are not different from each other in with respect to their COVID threat. Both equally perceive COVID. Both have equally perceived COVID threat, and which is that they don't perceive COVID as a threat, because their mean is more tilted towards disagreement. So how we will interpret this information? I will copy these two tables. Especially this particular table, the group means table. I will copy this table and I will paste it here. This table is already pasted here, and then I will try to interpret it. So just look at this interpretation. Hypothesis is rejected. Why? Because we found out that although the differences in mean are there, but these differences are not significant as depicted in our significant two-tailed column. The second value of significant two-tailed column must be lesser than 0.05. Because this value is not less than 0.05, we can say that the differences are not significant. So the hypothesis is rejected as shown in the table number. Let's name this table as 1. The mean of males is 3.12. The means of males is 3.12, and for females it is 2.94. In our scale, 1 stands for strongly disagree and 7 stands for strongly agree. Okay, we know it that in our scale 1 stands for strongly disagree and 7 stands for strongly agree. The p-value is 0.177. Now this is the p-value. We already discussed this. This is the p-value. The second value in the significant two-tailed test, this is the probability value, p-value 0.177. So the p-value is 0.177, which is higher than the stipulated level of 0.05. Therefore, we reject the hypothesis that males and females are different from each other with respect to the COVID threat. The mean values show that both males and females have similar orientation towards COVID fear, implying thereby that they are somewhat disagree with perception of COVID as a threat. Why I have used the word somewhat disagree? Because in my, you know, uh, values, 3 indicates somewhat disagree. So that is why I have used the word somewhat disagree here. So this is how you will interpret. This is a very simple, smart interpretation of your hypothesis. So if your hypothesis was that males and females have a different perception of COVID as a threat, then that hypothesis is rejected, and you need to interpret your hypothesis in this particular template. So this is the template that you need to show in order to interpret your hypothesis. So you can also copy the second table here, but the second table here, it requires lots of formatting because it is pretty lengthy. I don't think so it will come here. Yes, it will not come here. So you can do some formatting here, and present this table here, and also call out this table in your interpretation. The p value is 0.77 as shown in table 2. Okay. So you need to number these tables and format this particular table. This is a very lengthy table. Okay. So this is the t-test. Very simple. Usually the t-test is conducted when your IV has two response categories, like gender has males and females, and we form the hypothesis like this. We are very categorical whether our hypothesis is accepted or rejected. So our first statement is very categorical. So we are very straightforward in stating that whether our hypothesis is accepted or rejected. Okay. So, and we have a very reasonable explanation as well. So I have not explained here that why males and females, they have a they don't perceive COVID as a threat. Why? So this is not explained here. So you need to give reasons as here as well why they have not perceived. It may be referred to the overall culture of the country, or maybe because the data was collected when the first wave of COVID was subsiding. Okay, maybe so. I will write the explanation here. The reason being that reason could be that, because I'm not sure. The reason could be that the data was collected when first wave of COVID was being subsided. So fear of people, fear regarding COVID did not sustain well among people. Maybe this is the reason that why my sample does not feel threatened by COVID. Okay, so this is how you will interpret your t-test. Okay, so this is also done as well. So now we will see how to conduct and interpret our ANOVA test. Any questions so far? Anything which is not clear? Okay, so for our ANOVA test, hypothesis would be like this. So usually ANOVA test is conducted when your independent variable has more than two response categories. In our coding, we realized that uh, profession, it has more than two response categories. We have 5 response categories here. Okay, so the hypothesis here is this, that there are significant differences among different professions with respect to their perception of COVID threat. So we are stating that different professions will have different perception of coronavirus threat. So this is our hypothesis. So let us check this particular hypothesis. So I will go to the analyze button once again. There, I will, choose compare means, and in the compare means section, I will select one way ANOVA. So I have selected one way ANOVA. There are two boxes here. One is dependent list, and the second one is factor. In factor, I will put that independent variable which has more than two response categories. So that independent variable which has more than two response categories will go towards the factor box. So profession is that IV which we are focusing upon, which we are testing in our analysis here. So I will just put profession here in the factor box. So because this is one-way ANOVA, only one IV can be there. We discussed in our unit number 10 as well that we can also conduct two-way ANOVA, but we are only conducting one-way ANOVA here. Okay, so profession is in the factor box. Why? Because it is the IV, which has more than two response categories, and COVID fear. COVID fear is our dependent variable. So our hypothesis is there are significant differences among different professions with respect to their perception of COVID threat. Okay, so now um, do I need these buttons? Let me check. Contrast. No, nothing is needed here. Post hoc. Uh, yes, I can, choose these tests, but just for simplification, I will not choose these test options. Okay, I am interested in descriptive stats. I want to know the means of different groups, so I have just checked the descriptive box. That's it. Bootstrap, no, nothing else. Nothing is needed there. So among these four buttons, I have just selected options and checked the descriptive box. That's it. Now I will click OK. And here the two tables are very much prominent, the descriptive table and the ANOVA table. So I will again, first of all, read the means of these groups. So we have five groups. Full-time students, their mean is 2.8, which means that they somewhat disagree with COVID being a threat. Employees in private sector, their mean is 3.05, which again says that they somewhat disagree with it. Employees in public sector, again, the mean is around 3, which means that they don't perceive COVID as a threat. Own business, people who are entrepreneurs, they also perceive this, regarding, not as a threat. Full-time mothers, this is interesting. This shows that their mean is 4.26. It means that it is more leaning towards somewhat agreement. So they perceive that COVID is a threat. And especially the group is very interesting, full-time mothers. So those housewives who are dedicated towards the household tasks and taking care of their family members, by staying at home, they are full-time mothers. So they perceive that, COVID is a serious threat. So whether these differences are significant or not, remember that in ANOVA, if our ANOVA has to be significant, if our hypothesis needs to be confirmed, at least two groups should have significant differences. Now, just at the face value, it looks like that the mean difference is pretty large. See, there is 2.8 and there is 4.2. There is 3.05. There is 4.2. So the smallest mean is from students, the mean is 2.8, and the largest mean is the highest mean is from the full-time mothers. It is 4.26. So it shows that there is a difference in means, but whether this difference is significant or not, this will be explained in our ANOVA table. So we just need to look at the significant value here. So the significant value here, it must be lesser than 0.05. So this value, this significant value, it must be lesser than 0.05. So if this value is lesser than 0.05, which it is, it shows that there are at least two groups which have, significantly different means. So it shows that, yes, our hypothesis is accepted. Our hypothesis was that there are significant differences among different professions with respect to their perception of COVID threat, and our interpretation is very simple as well. So we will copy these two tables. I've already copied these tables, so we will copy these two tables in our output, the descriptive table and the ANOVA table. I will paste it here, and we will extract information from these tables and interpret our hypothesis. So our hypothesis is accepted. So we have categorically, stated that our hypothesis is accepted. Why? Because p-value is lesser than 0.05. P-value is lesser than 0.05. So we can add here that as shown in table, let's say it would become as table 4. The mean value for full-time students is 2.84. Now I'm explaining, you know, the information presented in table 3 shows that. So I need to title these, label these tables as well. Okay. So please don't forget to label these tables. Okay. So it showed that the mean value for full-time students is 2.84, employees is this, and for full-time mothers, the mean value is 4.27. As in our questionnaire, 1 stands for strongly disagree and 7 stands for strongly agree. It implies that full-time mothers perceive COVID as a threat as compared to other groups. And this is understandable as well because mothers by nature they are more concerned about the safety and well-being of their children and family members. So this is quite understandable that full-time mothers they will perceive COVID as a serious threat as compared to the full-time students or other people in our our group. So this is how you will interpret your ANOVA table, and this is how you will conduct your ANOVA test. So the hypothesis is accepted. So just keep this template in mind when you are interpreting your ANOVA or t-test, especially because this week's DQ activity is about these particular tests, the t-test, ANOVA test, and regression test. So you need to keep these interpretations in mind. You are required to interpret these tests. Okay, any question? So we have learned how to conduct and interpret ANOVA test. Now we will be doing regression test. Now remember that originally our hypothesis all required regression test in this particular uh, you know theoretical framework because we are using causal studies. Regression is always used when you are using causal studies, cause and effect relationships. So we have 3 IVs here and we have 1 DV. So we will check 3 hypotheses here. So each hypothesis relationship with COVID threat will be checked. So for it, I have already formulated a hypothesis. So the hypothesis is the personality trait of Machiavellianism is positively related with the fear of COVID. So this is the hypothesis that people who are more Machiavellianist in nature, they will have more threat of COVID. So this is the hypothesis. So the positively related is a key word here, and how I will understand that relationship is positive or negative, I will show you that as well. So now I will conduct regression analysis, and most of your hypotheses, I would say that majority of the hypotheses will be, um, you know, uh, you know, conducted will be tested by regression analysis. So I will go to the analyze, and in analyze there is regression button. In regression button, there are plenty of options for me, but I will choose linear regression, the most simplest regression analysis. So from analyzed, I will go to the regression, and from regression, I will enter linear regression. Okay, in linear regression, I have few boxes here, but I am only interested in these 2 boxes, the dependent variable and independent variable at the moment. So in the dependent variable box and the independent variable box, we have 2 boxes here. So our IV here was, in our hypothesis was Machiavellianism. So I have discussed earlier as well in checking ANOVA test, in testing, in checking the ANOVA t-test or regression, we will be using the indexes which we have created. So I will not be using these particular questions. All these questions won't be used now. So my IV is Machiavellianism. I'll choose the index of Machiavellianism. I will put it in the box here, and then I will choose the index of COVID fear and put it in the dependent box because it is clearly, stated in my, you know, theoretical framework. IV is Machiavellianism is an IV, and COVID threat is basically a DV. Okay. So I have placed my IV in the independent box, Machiavellianism and COVID fear in the dependent box. So do I need information from these particular buttons? Not at the moment. I don't need to, check on these particular options, these buttons. So I will just simply, click on OK. So when I click on OK, there are two tables which are very important for me. So in regression, these two tables must be given, due importance. The first table is model summary table and then the coefficients table. So you just need to copy these two tables and paste in your here in your report. I have copied these tables and I have pasted them here. So these are the two tables which are very important for me. Why are these tables important for me? Because they give me the information regarding my regression analysis. Okay. So first of all, just see how I have interpreted my, table. First of all, you need to understand that what information is provided by these tables. So the model summary table, basically, the most important value here is R square. R square shows you the percentage of variance, the percentage of change IV is producing in our DV. So the percentage of change, our IV, which is this particular, personality trait, producing in our DV is 6.1%. So this is 6.1%. So the change being produced in DV is 6.1%. So there is at least 94% change. So there are 94% reasons of perception of COVID as a threat, which are still not explained. But it is still okay because there are hundreds of reasons, which cause a perception of COVID as a threat. So we as researchers, we cannot, analyze all those hundreds of reasons. So we chose this particular variable, and this variable is explaining 6.1% change in my DV. So it is contributing to my DV just 6%. But is this contribution significant? So I need to check my coefficient table and I need to check significant value. The last, the value which is in front of adjacent to the Machiavellianism. So this value is lesser than 0.05. So it means that, my variation, the IV, the amount of change being produced by my IV is significant change. Even though this change is very small, 6.1% is not a huge change because 94% change is still unexplained. But this 6% is still significant change. Even this is small number, but it is still significant. So this is shown by my significant column in my coefficient table. So the significant column in the coefficient table will tell me whether the relationship is significant or not, whether my hypothesis is accepted or not. So whether this relationship is positive or negative, this will be represented by this beta value, the standardized coefficient value that is in my coefficient table. And this value, if this value is positive, this shows that IV has a positive relationship with DV. If this value is negative, then it shows that IV has a negative relationship with DV. So luckily, this value is positive, and originally in our hypothesis, we is positively related with a fear of COVID. It shows that our hypothesis is accepted. So we categorically state that our hypothesis is accepted. Now the template of interpretation which you need to use for your analysis. So the hypothesis is accepted. The p-value is lesser than 0.05. The as shown in, I would say, as shown in table 6, it would make table 6. Okay, the p-value is lesser than 0.05. This table has shown that the p-value is lesser than 0.05. The model summary table, which is the table number 5, shows that R square value is 0.061. R square value is 0.061, which implies that 6.1% variation or change in dV is explained by Machiavellianism. Okay, so the standardized coefficient beta is 0.247. The value is here in the coefficient table. The standardized coefficient beta value is 0.247, which shows that increase in 1 unit of IV will lead to an increase in 0.247 units of dV. This shows that relationship is positive. Okay, so although IV and DV are not moving in the same proportion, if IV increases by 1 unit, the DV will increase by 0.24 units. So 1/4 of the movement is corresponded by DV, but the relationship is positive, which is the most important information, which is provided by this particular column. So overall, so Machiavellianism has a significant positive relationship with COVID threat. Okay, so this is the interpretation. This is the interpretation of regression analysis. So similarly, you can do the regression analysis, and these tables, please, format them in a good way. Don't present it like these tables. Please label them and format them in a very good way, in a very formal way, and then you can show them in your analysis. So this is the interpretation of regression analysis. Any ambiguity, any question before I move on towards the last task of today's lecture? Any question about analysis so far? Anything which is not clear? Okay, so many students ask me that how to convert data from Excel to SPSS, because when you are collecting data through online medium, the data is usually collected in the form of Excel file. So this is how you can import data to the SPSS software. Go to the file. In the file, choose import data option, and usually the data is available in CSV form. So import data, go to the CSV data form, CSV option, open it. My data, the survey data is, it is basically mm, available here. Let me show you the data first. The data is very typical. This is the survey data. So it is like this, the data is like this: strongly agree, disagree. So all the questions are, in this particular form. Now I want to, convert them into the SPSS version. So I will choose file option, import data, and select the CSV data option. Click it here, open it. It is generating preview for me. Uh, just leave it like it is. Don't need no need to make any changes. That's it. Your data is here now. But the data is not in the form you would like them to be. So data is like in this form. You would like them to be in the numerical form. So first of all, you will make changes in your a variable view. For instance, all these are the questions without spaces. So like the first question is, kindly specify your gender. Okay, so you need to make corresponding changes in the variable view. For instance, we discussed that our data is numeric in nature. It is not string data. So our data is all numeric in nature. You need to make these changes. These are the nominal scales, but this is not on a nominal scale. These are all the Likert scale. These questions are measured on Likert scale. They are not measured on nominal scale. These are the personal information questions. The first, four, five, six questions. These are the, personal questions. These are measured on the nominal scale, and afterwards, all other questions are measured on other scales, which is the interval scale. So you need to make these changes. You need to make changes in the type of data as well. So you need to, make all the modifications in the variable view. So how to convert this particular data in the numerical form? Very simple. You go to the transform button. choose recode into same variable, and choose all these statements, all those questions which are being measured on strongly agree to disagree. Select them, shift them to the, these the variable box. Basically, it is showing string variables. It because it is being measured in the string form, but it should be measured in the numeric form. So you need to make these changes. I'm not making these changes at the moment. So I will click on old and if values. So I will just look at my yeah, here. So I will just make these changes. So strongly disagree is basically one in my data. I will add it here. So disagree is basically two in my data. I will add it here. Somewhat disagree is basically three in my data. Uh, ensure that you are following the same spellings which are in your file, otherwise there will be problem. Oh, yeah, there is an issue here. So somewhat disagree, we did not add it. Somewhat disagree is indicated by 3. Neutral is indicated by 4. uh, Somewhat agree is indicated by 5. Agree is indicated by 6. And lastly, strongly agree is uh, denoted by 7 in our questionnaire. So we'll add it, click continue, we will click OK, and you would see that all the data has been transformed now. The data is not transformed for strongly disagree because I thought that have used capital D, but there is smaller d here. So I will again go to the transform, again record into the same variable. Again, I will do this exercise. I will change it. This is basically, no, continue. Okay, and now I hope so. The data is changed. No, it is not changed. There is a problem here. Okay, let me fix the issue. Okay, so basically, the issue is only with this particular question. So I will just use this particular question. So yeah, somewhat strongly disagree. So basically, the problem is that I have used smaller d here, but I have used bigger, say, large alphabet, capital alphabet here. So I will remove this. Now, basically, it is strongly disagree is here. I hope so the changes are there. Yeah. Okay, so now my whole data is now transformed. I don't need to manually enter this information. My whole data is transformed. So similarly, you can make these changes for your gender as well. You can make these changes for your age section as well, profession as well, education as well. So these changes can be made for other variables as well. Okay, so this is it. This is how you can import data from Excel file, and how you can transform your data. So we have done our last step as well. Okay, so that's it. This lecture is now completed. Now let me discuss with you my uh, sorry. Let me discuss with you the uh, this week's DQ activity. This week's DQ activity is very important for you. Okay, let me load this file. Okay, so this is the this week's DQ activity. It is being shown in your slide as well. Okay, So this week, this DQ activity is very important. It is just, it is directly lifted from your lecture. You need to see the SPSS file, which was uploaded in your uh, unit number 11. You need to use that file again. It is the same file which was used for your analysis in Unit 11. It is the file which is uploaded with the theoretical framework document as well. So you need to use the same file. So you have already, done the factor analysis. Now you need to make indexes. You need to make indexes and conduct these tests. Conduct t-test for this hypothesis. There is a significant differences between males and females with respect to financial value. Okay, report your findings with tables and interpret it. Why do you think such results are furnished? Conduct an ANOVA test, after making all the indexes. I've mentioned it again and again that these tests are only conducted on your indexes. Okay, so, conduct an ANOVA test for this particular hypothesis. There is a significant difference among different age groups with respect to financial value of online banking. You know, Basically, it is only denoted by financial value. Conduct regression analysis on this particular hypothesis. The perceived privacy and security has a significant positive effect on financial value. So, report your findings with tables and interpret it. Why do you think that such results are furnished? Evaluate the findings of three other students and evaluate any differences in their interpretation. So deadline is 27th November and 29th November for your evaluation. So you need to, furnish, tables as well as the interpretations. Just make your analysis very formal, and you can check on the interpretations of other students as well. And a reminder about your assignment number 4, your research project. It is fast approaching. The 15th December date is fast approaching. Please be vigilant. Please be proactive in completing your assignment number 4. Okay. Any question about today's session? Anything which is not clear? No questions. Okay. So please go through the lecture. I think this lecture will be very helpful in performing your analysis and attempting your this week's DQ activity. Thank you very much for your time. Thanks for your patience. Thanks for listening. Bye bye.